All right, hello everyone, and welcome back to the next video here in Unit 2, where we're going to focus specifically on correlation. Correlation is something that is incredibly important here in terms of our second unit because it tells you how strong the relationship is between your two variables. So what I'm going to dive into a little bit is one, how do we describe correlation? Two, how do we use it? And three, we're going to talk about something called R squared, which takes your correlation and manipulates it a little bit. So let's jump right in. Correlation itself. This is just the textbook definition from the stats course and exam description, right? It gives the direction and quantifies the strength of the linear association. In reality, very simple to remember here. Your correlation lives on a number line between -1 and 1. Here, this is a perfect positive association. This is a perfect negative association. One thing I think that's really important for people to understand here is that a negative correlation is not a bad thing. It just means that the slope of your line is negative. So don't take a negative correlation to mean a bad thing. If we're talking about like hours practiced and 100-meter time, you would actually hope that that had a negative correlation. The more you practice, the faster that you end up running. And so a negative correlation is not a bad thing. And a positive correlation isn't always a good thing either. If we're looking at like the amount of cholesterol you eat and the incidence of heart attacks, right? That most likely, I don't know for sure, but that probably has a positive correlation. That is not a good thing. Right? We don't want people to have heart attacks. That's not a good thing at all. So when we talk about quantifying the strength, I'm going to put this in here. See if I can get rid of this little stray dot I made. Okay, perfect. Now, anything between 0.5 and 1, this area right here is strong. Anything between -0.5 and -1, we quantify as strong. And then anything here in the middle, we classify as weak. Notice there is no moderate, right? So strong or weak. And so the closer we get to 0, the weaker it gets. The closer we get to the ends of the number line, the stronger it gets. Now you may be thinking about the question of what if it is exactly 0.5? It won't be. It's the easiest answer I can give is that it won't be exactly 0.5. That's simple. So, but if it is at that point, maybe that you can call moderate. But otherwise, we are strong or weak, and that is it. Now, the coefficient of determination is when we take R and we square it, right? One thing that's also important here, R is also called, the other name for it is the correlation coefficient. This vocab is important because sometimes they'll ask you to interpret the correlation coefficient. Sometimes they'll just ask you to interpret R. So we need to make sure that we know both words to make sure we get the question right. Now, the coefficient of determination here, we literally take the R value and square it. So if R is 0.8, R squared is 0.64. If R is 0.9, R squared is 0.81. Like you just take it and square it. That's simple. This whole proportion of variation in the response variable that is explained by the explanatory variable, that is the sentence. If you are asked to interpret R squared, that you use. So we say the sentence here that's very important is R squared percent of the variation in Y can be explained by its linear relationship with X. And so in that case, whatever I have in quotations, fill in with context from the problem. And so we'll fill in the r squared, you fill in the y, and you fill in the x. Guaranteed credit. And if it's a multiple choice question, you're looking for the answer that most closely matches this. Sometimes you'll see proportion, sometimes you'll see percentage. It all depends. But in a multiple choice question, you're looking for the closest to that wording. In an FRQ, you're just saying that sentence outright. Now, the thing to be careful about is that sometimes they'll give you r and ask you to interpret r squared. Sometimes they'll give you r squared and ask you to interpret r. So make sure you read the question closely so you know which thing they're asking you to do. Don't take for granted that you're just given the number you need to interpret. So be careful. Now, interpolation versus extrapolation. This is a very important topic. Very simple. Interpolation is just predicting between known x values. And extrapolation is predicting outside of your known x values. One thing that's very important. Extrapolation is never, ever, ever appropriate. Interpolation, completely fine. Right? If I have, an x equals 20 and an x equals 30 and I want to predict 25, totally cool. Outside of your data set, I have no idea if my relationship remains linear. So extrapolation is never, ever appropriate. I don't care if it's one more. Right? I don't care if the maximum x value is 50 and I want to predict 51. Doesn't matter because I have no idea. If you can't tell by the size of what I just wrote, never, ever appropriate. And you will be asked about it. Case in point, right here, this question. Would it be reasonable to use, this is only one part of one question, but I picked the part that talks specifically about the interpolation versus extrapolation. Would it be reasonable to use the regression equation to predict the fuel consumption for a train on this route if it had 65 rail cars? Well, the max I have is 50. No. The max is 50, and I don't know if it stays linear. Extrapolation is never, ever, ever appropriate. The biggest thing I can drive home in this video, never extrapolate. And like I said, you will be asked about it. So I don't care how strong, I forget what the r squared was for this, but it was very high. It was like 0.94 or something like that. It was an incredibly strong r squared. Doesn't matter. Right? And actually notice this is the same question from the previous video. It was just the next part of it. So that is it for our real basics on correlation. I hope this was helpful, and I'll see you in the next one.